All right, I'm going to go through a couple examples of the type 1 and type 2 errors and power. One personality test available on the World Wide Web has a subsection that's designed to assess the honesty of a test taker. After taking the test and seeing your score for this subsection, you're interested in the mean score among the general population on this subsection. The website reports that the mean is 142, but you believe that the mean is greater than 142. To do a statistical test, you choose a random sample of 75 people and have them take the personality test. Suppose the population of the score on the subsection of the personality test has a standard deviation of 25, and that you perform your hypothesis test using a 0.1 level of significance. So I'm going to slide down here. First of all, we're talking about that the mean is greater than. So that's going to be my alternative hypothesis. I'm going to slide down here. So you can see here for the alternative hypothesis, it's greater than the 142. Then the null hypothesis, since this is a greater than, would have to be less than or equal to 142. So this is going to be a right-tailed test. What is the probability you commit a type 1 error? Your type 1 error is the same as your alpha value. So if I slide back up to the top to the question, it told us that the level of significance was 0.01 level of significance, and so that's going to be your alpha value. Now, the next thing they're going to ask you about is assuming that the actual value of the mean is 151, what is the power of the test? The power of the test is the probability of accepting your alternative hypothesis. So this is where it gets kind of tricky, and you're trying to decide, do I do P of Z is less than or equal to, or do I have to do the 1 minus P of Z? First of all, you have to calculate your C value. So I'm going to go ahead and grab the graphing calculator here. And in order to calculate that value, I'm going to do my Z sub, my alpha value, 0.01. I'm going to multiply that by the standard, or the standard deviation. The standard deviation, if I slide this over, was 25, divided by the square root of the number of people in my sample, which is 75. I'm going to close my parentheses there. I'm going to add my U sub 0 value, which is the 142 that I was trying to see if I'm greater than. So adding 142 to that, I get my decimal, or my 148.7155. I'm not going to round that off. I'm just going to leave it on my calculator, because then the next part of my formula is I'm going to subtract U sub 1. U sub 1 is this 151 that is the actual value. So minus my 151. I'm then going to divide that again by the standard deviation over the square root of n. So the 25 divided by the square root of my 75. That gives me the value that I'm going to use with the P of Z. I'm going to go ahead and click on that. So you have to decide, do you just leave it as P of Z is less than or equal to, or do I need the 1 minus? This is where you have to think about your normal curve. On my normal curve, when I'm doing a right-tailed test, which is what I'm doing, on my right-tailed test, my alternative hypothesis is to the right. I am trying to find the probability of accepting my alternative hypothesis because I'm doing my power test. So since I'm going to the right, I have to do the 1 minus, because the P of Z does to the left, because it's less than or equal to. So since I'm going to the right side of my curve, I have to do 1 minus the P of Z is less than or equal to that value. I'm going to hit equals here. Rounding that off, I would have 0.79 to 2 decimal places. So if I slide down here, you'll see that I have 0.79. The next part, it says, suppose you decide to perform another statistical test using the same population, the same null and alternative hypothesis, and the same level of significance. But the second test, you choose a random sample of 50 instead of a random sample of 75. So what you did is you decreased the number of people in your sample. So when you decrease the number of people in your sample, the probability of committing your error is going to be higher. The more people you have, the less chance you're going to make an error. So since I went from 75 down to 50, I now have a higher probability of committing my type 2 error. So the probability of my test is going to be greater, as you can see there. So I'm going to go to more practice, and we're going to work through one here. It says a scientist has read that the mean birth weight of babies born at full term is 7.4 pounds. The scientist believing that the mean birth weight of babies born at full term is less than this value plans to perform a statistical test. She selects a random sample of 100 birth weights of babies born at full term. Suppose that the population of birth weights of babies born at full term has a standard deviation of 1.6 pounds, and the scientist performs her hypothesis using the 0.1 level of significance. Based on this information, we're going to answer the questions below. First of all, our hypothesis. The scientist believes the mean birth weight is less than this value. So our alternative hypothesis is less than the 7.4 pounds, which means our null, which has to include the equal to, is the greater than or equal to 7.4 pounds. That means we're doing a left-tailed test. Assuming the actual value of the mean is 7.04 pounds, what is the power of the test? So again, the power of the test wants to know the probability of accepting the alternative solution. Since the alternative solution is going to be to the right on my, no, it's going to be to the left because I have the less than. I'm not going to use the 1 minus on here. But first of all, I have to calculate my values. So I am going to go ahead and grab my calculator. And again, I am going to go ahead here and do my left-tailed test. Since I'm doing my left-tailed test, I have to use negative z. So negative z sub 0.1 parenthesis. The standard deviation of 1.6 divided by the square root of the number in the sample of 100. Close my parenthesis. I'm going to add the mean sub 0, which is the 7.4, and that's going to give me my C value. I'm going to take that value, I'm going to subtract the value from the question U sub 1, which is the 7.04. Ooh, I hit something. 7.04 equals, I'm going to divide that by the standard deviation, which is 1.6, divided by the square root of n, which is 100, and hit equals. That gives me my value that I'm going to put in my P sub z. So again, thinking about, do I need the 1 minus or not? I'm thinking that this is a left-tailed test, less than. So when I do the less than, my alternative solution is to the left. My null solution would be to the right. So since I'm finding the value to the left, because I'm doing my power test, and my power test means I'm accepting my alternative solution, I don't need the 1 minus because I'm finding the value to the left of my critical value. So I'm going to hit equals here, rounding off to 2 decimal places, 0.83. The probability that on the next part, that the scientist rejects the null hypothesis when in fact it's true, that is committing a type 1 error. The probability of committing a type 1 error is your level of significance, which in this case is 0.1. And then this part down here. Suppose the scientist decides to perform another statistical test using the same population, the same null and the alternative hypothesis, and the same level of significance. But for this second test, the scientist chooses a random sample of 75 instead of a random sample size of 100. So my sample size decreased. I went from 100 down to 75. What's the probability of committing a type 2 error? So again, on this one, when the number of people in my population decreases, the probability that I'm going to commit my error is going to go up. The less people I have in my sample size, the more likely I'm going to make an error. So you can see we got that correct. We'll do one more. I'll go to more practice here. It says a union of restaurant and food service workers would like to estimate this year's mean hourly wage for food service workers in the U.S. Last year's mean hourly wage was $8.08. There is reason to believe that this year's value is greater than last year's. The union decides to do a statistical test to see if it can be concluded that the mean has increased. The union chooses a random sample of 100 wages from this year. Suppose the population of hourly wages of food service workers in the U.S. has a standard deviation of $1.25 and that the union performs a hypothesis test using 0.01 level of significance. So what are our null and alternative hypotheses? The reason to believe that this year's value is greater, since it's the plain greater, that's going to go in my alternative hypothesis, greater than $8.08. Which means my null is less than or equal to $8.08, which means we're going to do a right-tailed test. So, assuming the actual value of the mean is $8.48, what is the probability that the union accepts the null hypothesis? So in this case, when you're thinking about this, it's a greater than for the alternative, so the null is the less than or equal to. So the null is going to be on the left side of your critical value, which means that you're just going to do the P of Z. First of all, we have to calculate our C value. We are doing a greater than, so we are going to use the plain Z sub. Since we're doing a right-tailed test, 0.01. We're going to multiply that by the standard deviation of $1.25 divided by the square root of the number of the people in the sample, which was 100 people. Close my parenthesis. I'm going to add the mean sub 1, which was $8.48. $8.48. I'm going to get my value. Just leaving that in there. Once I have that value, I am going to, oops, I added the wrong value. Let me undo that. It wasn't $8.48 there. I want to add my mean sub 0. My mean sub 0 is the $8.08. Put the right number in there, $8.08. So Z sub 0.01, the standard deviation over the square root of n plus mean sub 0, which is my $8.08. Now I'm going to hit equals. I'm going to leave that value in there. Then I'm going to subtract my mean sub 1, which is my $8.48. 8.48. I'm going to divide that by the standard deviation, $1.25, divided by the square root of n, which was 100, and that gives me my value that I'm going to put in there. So I'm going to hit the P sub Z to pop that in there, and then again talking about, do I need the 1 minus or not? I want to figure out the probability that we accept the null. The null value is the less than or equal to. Since this is the less than or equal to, we don't need the 1 minus. I'm going to go ahead and hit equal, and we have 0.19. Probability that we commit a type 1 error, again, that's the same as our level of significance, 0.01. And then the bottom question, suppose the union decides to perform another statistical test using the same population, the same null and alternative hypothesis, and the same sample size. But for this second test, the union uses a significance level of 0.05 instead of a significance level of 0.01. So we went from 0.01 was our starting to 0.05. So we went from 1% to 5%. So I increased my alpha value. Wants to know what happens to my power. So my power should also increase. So I went from starting at a 1% level to significance to a 5% level of significance, which actually gives me more room for error. So the power of my second test is going to be greater than the power of my original test. I'm going to go ahead and hit check on that. And you can see again, we got that one correct. Do one more just in case we need another example. A coin-operated coffee machine made by a big corporation was designed to discharge a mean of 7.2 ounces of coffee per cup. If it dispenses more than that, on average, the corporation may lose money. If it dispenses less, the customer may complain. Believing that the mean amount of coffee dispensed by the machine is greater than 7.2 ounces, Big plans to do a statistical test of the claim that the machine is working as designed. Big gathers a random sample of 150 amounts of coffee dispensed by the machine. Suppose the population of amounts of coffee dispensed by the machine has a standard deviation of 0.9 ounces, and that Big performs its hypothesis test using a 0.1 level of significance. So again, on this one, the hypothesis here is that it dispenses by the machine is greater than 7.2 ounces. So my alternative hypothesis is the greater than 7.2. That means my null hypothesis is going to be the less than or equal to 7.2. Let me go back to here. What is the probability that Big rejects the null when in fact it's true? Rejecting the null is a type 1 error. So what's the probability of committing my type 1 error? That's my level of significance. I don't have to do any calculations, 0.1. I jumped ahead, I was trying to do the next part. So 0.1. Now if I go to the one where we actually have to do the calculation, assuming that the actual value of the mean is 7.35 ounces, what is the probability that Big commits a type 2 error? So if I'm going to commit a type 2 error, it's accepting the null. So when I'm committing a type 2 error, I'm accepting the null, which means I am going to do the less than or equal to, and so I won't need the 1 minus because I'm doing the less than or equal to, which is my null hypothesis. So again, starting out with my calculations, let me start this over here. I am going to do greater than. I'm still doing a right tail test, even though this is committing a type 2 error. So I'm going to do my Z sub, and my level of significance was 0.1. I'm going to click up there in parentheses. I'm going to do my standard deviation, 0.9 divided by the square root of n, which was 150. To that, I am going to add, close my parenthesis there, my mean sub 0, which is my 7.2, and hit equal. I'm going to take my C value. I'm going to subtract the actual value. So from that, I am going to subtract my 7.35. I'm going to hit equals. I'm going to divide that value by my standard deviation, 0.9, divided by the square root of n, which is 150, equals. There's my value. I'm going to put it in the P of Z. So again, trying to decide, do I have to do the 1 minus or not? The question says, what's the probability that they commit a type 2 error? A type 2 error, you accept the null. The null is the less than or equal to. We have the less than or equal to, so we don't need the 1 minus. I'm going to hit equals there, rounding that off to 2 decimal places. 0.22 is going to be my answer. Suppose that Big decides to perform another statistical test using the same population, the same null and alternative hypothesis, and the same level of significance. But for the second test, Big chooses a random sample size of 75 instead of the random sample size of 150. So he went from 150 down to 75. He decreased the number of people in his sample. What happens when you decrease the number of people in your sample? The power of the test is going to go down. So the power of my test is going to be less than. And so if I go ahead and check that, you can see there again, we have the correct on there. So hope this helps in a few examples there. Let me know if you have any more questions, and good luck.